we need equations of tangent lines and of horizontal tangents, so that means we need derivatives. Okay, so the derivative of a constant is nothing. The derivative of cotangent, we can take this for granted. It's negative cosecant squared x. Okay, because the point is past where we ask students to keep proving that again and again. You can just say every time I take a derivative of cotangent, it's negative cosecant squared x. And same thing over here. Every time I take a derivative of cosecant, I can say negative cosecant x cotangent x. Okay, every time I take a derivative of cosecant, I can replace it. And let me just clean up that derivative a little bit because of the negative signs over there. It's a negative times a negative makes a positive. So we got positive 2 cosecant x cotangent x. Okay, so that's the first part. Trig derivatives is just a matter of plugging in what the derivative is supposed to be, unless you're asked to prove something. The derivative of sine is cosine. Boom, you're done. That's the derivative. The derivative of cotangent is negative cosecant squared x. Boom, you're done with that derivative. Right, just replacing those. So that's the derivative. We're asked for the tangents. Let's start with p. That red line, we're trying to find the equation for that red line. Okay, so I think it says in the book, I didn't make this very clear, but it's supposed to be at pi over 2 for p. So we want to know what the slope is. What's the m? We know what we want to know what's the b at at x equals pi over 2. So to find out what that tangent slope is, we got to plug in pi over 2 in for the derivative. So in the derivative, negative cosecant squared pi over 2 goes in here. Okay. Don't need that equal sign because it's not equal to anything. Then we need cosecant pi over 2. And then we need cotangent pi over 2. Okay, so you can use your calculator, and I encourage you to double check. Just make sure your calculator's in radians, but we should leave calculus knowing how to do these things without a calculator. Okay, and so I'll show you. Pi over 2, remember anything inside a trig function, inside the argument, is an angle measurement. Pi over 2 is in radians, but that's 90 degrees as an angle. And cosecant is the reciprocal of sine. So if we can figure out what sine is, cosecant is just 1 over that answer. And sine is always the y coordinates on the unit circle. So we drew our angle. If it's the unit circle centered at 0, that means this is 0, 1. So sine is 1 here. So cosecant pi over 2 would be the reciprocal, which is just 1, right? So it's going to be 1. 1's going to be squared. That makes negative 1. Same thing over here. We already said cosecant is 1, so we're going to put 1 in there. Now cotangent pi over 2. Cotangent is the reciprocal of tangent. So cotangent is cosine of x over sine of x. And at pi over 2, at this angle measurement, cosine is the x coordinate, so it's 0 over 1. So this is 0. Cotangent pi over 2 is 0. But then you could check that with the calculator. That all multiplies to make 0, so we've got negative 1 for our slope. That's the slope of that red tangent line, because we plugged in its x-coordinate, and it spit out a slope of negative 1. And then to find b, we need to know what the y-coordinate is. So we want to go back to the original function for location. We want to plug in pi over 2, because we want its corresponding y-coordinate at pi over 2. And if you do that into the original function, cotangent pi over 2 we said is 0. Cosecant pi over 2 we said is 1, so this is 4 minus 2 makes 2. So that's the x and y coordinate that we want to plug in. So you're plugging in 2 in for y, pi over 2 in for x, and then you're solving for b. So you can add that pi over 2 to both sides, so you're going to get b equals 2 plus pi over 2. So in other words, y equals negative 1x plus 2 plus pi over 2 is what we should say over here. Okay. That's a 2. There's our full equation. And then the horizontal tangent. Horizontal tangents happen when the derivative is equal to 0. So I'm going to plug 0 into this side of the equation and then solve for x. So I've got 0 equals negative cosecant squared plus 2 cosecant x. cotangent x. Okay, and then if I'm trying to get x by itself, I could factor out a cosecant from both of those. So if you do that, cosecant x goes on the outside, then you've got negative cosecant x here, because I factored out one of those two. And then this is plus 2 cotangent x. So if you could make cosecant x equals 0, then you're in business, right? Because 0 times everything over here would be 0, but it can't happen. You can't make cosecant equal to 0. And here's why. We're trying to say what value for x would make this equal to 0. Remember, cosecant is 1 over sine. Can you ever plug a number into a denominator to turn your fraction equal to 0? Even if you could make this equal to a billion, which you can't, but even if you could plug in a billion, 1 divided by a billion is not exactly equivalent to 0. So there's no way of making this equal to 0. So let's check in here. Is there a way of making this equal to 0? So we're solving a smaller equation now. Can we make that parentheses equal to 0? Because if we can, then we've got it. So to do that, I'm going to add that cosecant to both sides. And if I'm not sure what to do, I usually turn things into sine and cosine. So cosecant is 1 over sine of x. It's just the definition of cosecant. And cotangent, another way of writing that, is cosine of x over sine of x. So I see an algebra step I can do to make my life easier. We both have these in the denominator. Let's multiply sine of x to both sides. Getting closer. Let's get cosine of x by itself, so we'll divide 2 from both sides. Equation's getting simpler and simpler, and so now the question is, what value would you plug in for x to give yourself a trig ratio of 1/2, positive 1/2? So you can answer that question by drawing the only two places where cosine is positive, here, and all students take calculus, cosine is also positive down here. And you want to draw these in the unit circle. It's just to make your life easier, though. You could draw these outside the unit circle too, but we can memorize values, just a couple values to help us with the unit circle. And we want cosine to be 1/2. So this is your reference angle. Cosine is always not the opposite side, but the adjacent side divided by the hypotenuse. So this adjacent side has to be 1/2. That way, adjacent divided by hypotenuse would give us 1/2 here. And if you've memorized these triangles, you'll know that this has to be square root of 3 over 2 according to the Pythagorean theorem. So the angle that's across from square root of 3 over 2 is a 60-degree angle. So that means x equals 60 would be the x location for where we have a horizontal asymptote. Okay, we plugged in 0 in for the derivative, and after some tricky algebra, we found out x equals 60, or if we want that in terms of radians, 60 divided by 180, and stick a pi in there. That's pi over 3. Right, and then there's another one you could find out down here. That'd be 300. That'd be 300 degrees all the way around. So x equals 300 would also work. Since pi over 3 is just a little bit to the right of 1, we know that's the right one, right? Because that's right around pi over 3 on our graph. Okay, all we've done now is we found out the x coordinate where we have a horizontal asymptote. Okay, you got to repeat the steps that we did up here to construct an equation. Well, actually, no, we're done. Sorry. Ooh, I thought it was going to be worse. Because look, it's a horizontal asymptote, so the slope has to be 0. And then in order to have a y-intercept of pi over 3, we have to have pi over 3 for our y-intercept. Because if it's a horizontal line, it's going to cross at that y-coordinate. So the equation of the horizontal tangent is the equation of any old horizontal line. It's y equals something. And we found out, wait. No, that's not a y-coordinate. Sorry. Maybe I'll back up this video, but okay, so now we have x equals pi over 3. We got to find the y-coordinate, which I messed up. So if you want the y-coordinate, you got to plug pi over 3 back into your y-coordinate equation right over there. So we want pi over 3 in for x and see what it spits out for y. So y equals 4 plus cotangent pi over 3. Subtract 2 cosecant. pi over 3. Okay, so cotangent pi over 3, we said that's a 60-degree angle. We can draw that triangle again. Looks like this, and we said this side was square root of 3 over 2, and this is 1/2. We've already drawn this triangle. Cotangent is the reciprocal of tangent, so cotangent should be the adjacent divided by the hypotenuse. The adjacent side, sorry, the adjacent divided by the opposite. Let me say that again. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent divided by opposite. Adjacent divided by opposite. So cotangent is 1/2 divided by square root of 3 over 2. Okay, so we'd flip and multiply that other fraction. The 2's would cross cancel, so you get 1 over the square root of 3, but the convention in math is not to have square roots in the bottom. So multiply the top and the bottom by square root of 3. Okay, so that's what cotangent pi over 3 is without a calculator. It's square root of 3 over 3. And then we're supposed to subtract by 2 times cosecant pi over 3. Cosecant's the reciprocal of sine. So if sine is opposite divided by hypotenuse, cosecant is hypotenuse divided by opposite. So you'd flip and multiply, so that's 2 over square root of 3. But again, we don't like square roots in the bottom. So multiply the top by square root of 3 and the bottom by square root of 3. Square root of 3 times square root of 3 makes 3. That's the whole point of multiplying it by square root of 3. Okay, and we're almost done. You got 4 plus square root of 3 over 3, and then it's minus 2 square root of 3 over 3. So we get 4 minus, oh wait, these aren't the same, sorry. This is 2 times, so you could just say this is 4 square roots of 3 over 3. Multiplied the 2 to the inside. So it's 1 of these subtracted by 4 of these, so that makes minus 3 square roots of 3 over 3. Oh, okay, but that's nice. The 3's cancel out, so here we go. That's the y coordinate. At x equals, what do we say, pi over 3, we got a y coordinate of 4 minus square root of 3. So that means that this has to be y equals 4 minus square root of 3.